Okay, good afternoon, everybody. It's an absolutely beautiful day in Birmingham, and I hope as many of you as possible can be sat outside under canopy cover, enjoying the canopy cover. Welcome to the TDAG meeting on resilience through canopy cover. TDAG is a network and a forum that brings together people and organisations to support the role of urban trees through better collaboration in the planning, design, construction, management and maintenance of our urban places. Knowledge exchange and information sharing is really important to us. That's the purpose of these seminars. It's for us to share information and for you to ask questions, share your information, and we really encourage questions and participation. We would really like to thank the partners for us who have helped raise awareness of the event and share it among their members. So today our partners are the Arboricultural Association, the Institute of Chartered Foresters, the Landscape Institute and the Urban Design Group. Last but not least, I will pass you over to the chair for today. Today's meeting will be chaired by John Rose, Senior Urban Forest Consultant at Tree Canopy. So, fun story, John and I actually met about 4 years ago when he was retraining as an MSc student in urban forestry. I think he's hit the ground running and he hasn't stopped moving. And John, over to you.
Okay, thank you, Emma. Right, hello everybody. I said my name's John Rose, work as an urban forest consultant for Tree Canopy, work with local authorities up and down the country, and that is from helping them understand their urban forest and plan how to improve, expand and grow them going into the future. That can be canopy cover studies at one end and urban forest master plans at the other. Hence we've been working with sort of Birmingham and Belfast. So, but today we're here to talk about resilience through canopy cover. Why? So, personal perspective, we're planting a lot of trees, thousands, hundreds of thousands, millions of trees. It's taking a lot of people, a lot of time and effort, and it's sucking up a lot of funding, soaking up a lot of funding, quite rightly so, for all sorts of reasons that we're very familiar with and new ones that are emerging every year. But it is only right that we should measure the impact, and we have an obligation to the public to kind of demonstrate the achievement that's being gained for the effort. Now the chosen metric for this has been canopy cover, hence today's topic, and it's a very nice simple measure. It can be brought down to a number, and therefore it's been seized upon by our elected representatives. It's quite useful in that sense. England has a canopy cover goal, albeit it's been adjusted. London has one. Many cities up and down the country have one. Anybody working with 330, 300, you've given yourself a canopy cover goal. And if we go back a couple of years, 2023, Natural England launched the GI framework. And within that, one of their 5 standards was urban tree canopy cover. That has 2 elements. It has an area goal, an area element. So at local level, we have to set a benchmark and set a target to expand our canopy cover, and a site goal for major developments of commercial or residential, looking for those individual developments to contribute towards that area goal. And that again locks on to the December launch of the National Planning Policy Framework, where existing and new trees are to form part of new developments, and new streets are to be tree lined. And there's a lot of elements within the NPPF that are positive moves for trees, albeit got swept away in the news by all the stories about sort of grey belts. But there's a lot in there on sort of and ages of veterans found their way into it for the first time. Although that's a topic for another day. Now, back to canopy cover. It's not so simple in practice. So how do we make it work in practice? How do we compare the same location at 2 different years? How do we compare 2 different cities? How do we come together to have a common approach so that we're all working in the same place? We're not trying to work out how the thing works at all. We need a common approach. We have today, to try to tackle that, we have 5 speakers who range from those who are the research end of the scale to those who are practitioners making it work on the ground. So we're gonna get right underneath that. One of the things about these sessions is a massive opportunity to learn and to collectively learn. And so hopefully you've all got curious minds and you have an opportunity today to ask questions, a rare opportunity to put them to those who are sort of with the experience in the field. So do make good use of the chat and we'll have a good opportunity to get through those as we come to them. So it now is for me to hand over to our first speaker. So can I introduce you to Deanne Brettle, PhD candidate from the University of Birmingham and lead author for the TDAG Canopy Guides. So over to you, Deanne.
Lee, if you're speaking, we can't hear you.
Yeah, sorry, bear with me a second. Just trying to get my video on. Oh, yes, hello. Sorry about that. Good afternoon, everyone. So my name's Deanne and I'm a PhD student at the University of Birmingham, where I'm working on a European research project called Carmine, which is about climate resilience and how we can help our cities prepare. And my main area of research is around urban forests and tree establishment. But I also provide the admin support for TDAG. So it's me that usually pops into your email account a couple of times a month to send you the TDAG newsletter and also to remind you to sign up to our handy seminars. All of our seminars are recorded and put online onto our YouTube channel. And you can see the link in the top right there. But TDAG also provides a lot of useful resources. Again, these can be found on the website. And we have what we call the First Steps guides. Now, a First Steps guide is usually very short, just 4 pages, and they should be easy to use with easy to read with limited jargon. And what they do is they signpost to other useful information. And they normally contain a few handy diagrams and at least 1 to 2 case studies. And the authors really give their time to write these First Steps guides. And as I say, they're all available to download for free on the website. And we've been working most recently on a First Steps guide around urban tree canopy cover. However, the area is so big with potentially 2 different audiences. So what we've done is we've split this into 2 parts. So we have part 1, which is now available on the website. And this is First Steps in Urban Tree Canopy Cover, a strategic approach for urban forest planning. And this is really thinking about how you can calculate canopy cover on a larger scale, so at a neighbourhood, ward or regional scale. And then the second part, First Steps in in canopy cover assessments, is for all working in the built environment at a development site scale. And so this is really about how you can calculate canopy cover at smaller scales. And this guide will be coming out soon. Both of the guides start with an explanation as to what canopy cover is. And the definition we use is that it's a 2-dimensional representation of the area covered by the branches and foliage of trees, and it is usually expressed as a percentage. So if we take a crude example of this, you can see this image on the right. If we look down, we can see that roughly about 60% of this area is covered by the foliage and branches of trees. So we could say, therefore, this has about a 60% canopy cover. And thinking about land areas in this way is perhaps a little bit more useful than simply talking about tree numbers, because we could say that an area has 50 trees, but it doesn't give an indication as to the size of those trees and therefore the ecosystem services that they provide. Or we could say that each of these neighbourhoods have 50 trees. But again, if you look down at these images, hopefully you can see that one area has a greater canopy cover than the other. And being able to say how much of an area is covered by canopy, so being able to quantify the canopy cover, is really useful, because the data can then be used for various things, such as setting targets and also monitoring changes over time. Now, to calculate canopy cover, you're going to have to be a little bit more scientific than what we've been doing so far, just looking and kind of estimating. You're going to need some data and processes to follow. And these are explained in the first steps guides. So the first one is looking at how you can calculate canopy cover using methodologies that look down from above. And inside, you'll find a handy table of resources that can be used for this. And it separates these into data which you can obtain and then process yourself, and then data which has already been processed and the calculations have been done for you or can be done for you. It's important to note that using a different calculation or different methodology can provide different values. So what we recommend is that you choose one method and then stick to it so that you have consistency over time. And once you've got your data, you can make handy maps like this. This is a map of Birmingham, and you can see that some areas are darker green, and this indicates a high level of canopy cover, and some areas are lighter green, indicating a lower level of canopy cover. And maps and data in this way can really be very powerful. We do say in our document that using the canopy cover metric is not perfect, and the guide explores the advantages and the limitations of using the canopy cover metric on its own without additional tree inventory data. The second part 2, which is coming out soon, looks at a different process of measuring canopy cover, wherein you actually go to the site and you measure the trees and then plot the spread of the trees on a scaled map. And this document, as I say, will be out soon, and here's a sneaky peek. The first point to make is that canopy cover assessments are in the early stages of development, and what this first steps guide does is it doesn't dictate a method. What it does is it provides basic information about what you can expect to find in a canopy cover assessment. And it gives signposts to information and discusses the advantages and limitations of this process. And what we say is that we foresee that there's going to be great innovation in the way that canopy cover assessments are completed, and that these are a kind of starting point to work from. And that when these new references come up, we'll be adding to this document and adding it in new case studies as well as they come in. The first steps guides have been written by myself, Jeremy Barrell, Kieran Doik, Emma Ferranti, Sue James, and we also have to give sincere thanks to Russell Horsey, Kenton Rogers, John Rose, and Matt Underwood. And as usual, the TDAG guys have been, the graphics have been provided by Steve from Reduction. So that's everything I had to share about the two TDAG guides. I'm sure that our other speakers will have lots more to add, but I shall be around if you wanted to pop any questions in the chat. Thank you.
Excellent. Thank you, Deanne. That's a really good introduction to today, and that's a really good guide. Everybody should take a good look at that. Right. Are there any questions immediately for Deanne? I'm suspecting possibly not, because we're really at our
no,
sort of stage.
Not as yet, John, not as yet.
Thank you very much, Deanne. Right,
Thank you.
we're sort of warming up. Okay, in which case, can I turn to our next speaker and welcome Hannah Walker, Urban Forest Research Scientist from Forest Research, who will outline the strategic approach to canopy cover, the First Steps Guide, Part 1. So Hannah, over to you.
Thank you, John. Can you hear me and can you see the slide okay?
Yes, thank you.
That's great. I'm presenting today on behalf of Kieran, who's not able to be here today, so we've developed this presentation together. And the title is A Strategic Approach to Canopy Cover, but as already alluded to, I'm going to focus quite a lot on the challenges associated with canopy cover assessments and using them to make decisions. So why are they important? Why are canopy cover assessments important? Canopy cover indicates tree presence, as we've already heard, and it indicates potential provision of benefits by urban trees. And if we do a citywide or area-wide assessment, we can find places that have less tree cover or simply don't have enough tree cover. Canopy cover can be estimated using reliable, quick, reproducible and repeatable measurements, but there's a lot of caveats associated with that, and we'll come on to that shortly. And they can be combined with other spatial data, such as social deprivation or urban temperatures, urban heat island data, to help us plan where to increase canopy cover in the areas that have greatest need. And I'll show very briefly a good example of this later on. If we don't measure canopy cover, we can miss key trends, such as declining tree cover in our towns and cities. We don't know where trees are present and absent. We can't meaningfully set realistic canopy cover targets or timeframes in which to meet those. And we may not know whether our schemes or interventions to try and increase tree cover are working. But there's a lot of things that canopy cover on its own cannot tell us. So a canopy cover assessment doesn't tell us anything about the ownership of the trees in terms of public or private ownership or management. Nothing about health or condition, generally speaking. We don't learn about the diversity in terms of species, age and size. We don't know whether the trees that are present are suitable for our current and future climate and for the site that they're on. We can't really tell whether they're accessible to people in order that they can gain the benefits from the trees. And crucially, when we're thinking about new planting, we often miss the presence of really small trees, so newly planted trees. And there's a whole load of other things that canopy cover on its own cannot tell us. It's quite difficult to choose the right canopy cover data, so that's the existing data that Dee mentioned, or the right assessment approach for your work. So you have to think about how you're going to use the data, and you must have a clearly defined aim before you even start, I think, and that is indicated in the guide, and that's a really good point. We have to think about what you can afford, because some options are free and some options cost a lot of money. You have to think about how quickly you need the data. Again, some options take time to gather and some are available instantly. The size of the area that you need to cover. So if you're going to do a manual assessment, you'll need to be aware that that will take some time. You need to know what the smallest geographical scale is. So do you want to look at LSOA level, or are you bothered about wards, or do you actually want to know where the tree cover is? Will you need to monitor change? Do you want to compare to other towns and cities? And in which case, what approaches or methods or data have they used? And as we mentioned before, do you need to be able to detect small tree sizes? And in terms of data or methods that already exist, is that method verified? Are there measures of uncertainty reported with it? Have there been method changes during the lifetime of that product, and what are the impacts of those method changes? So a simple example might be a change in image resolution enables you to detect much smaller trees than, for example, 10 years ago. And that might make it look like you have an increase in canopy cover, but really it's an increase in what's visible. Do you expect the producer of the data to change the method in the future? And do you know what those impacts will be? Does the data come from one time point, or is it a composite of dates? And that's a really common feature of canopy cover data. And do you know if you need to measure change, can you reasonably expect that the data will be updated in the future for you to be able to monitor that change? And this is just a snapshot of considerations, and the more you get into this, the more complicated you realise it is. So here are some examples, a really quick look at existing canopy cover data, and these are given in the TDAG guide as well. So we have a tree map produced by Friends of the Earth, and this is free at local authority and lower super output area scales. It's based on Environment Agency data, but they did their own processing. It has a 1 meter resolution, but the underlying data comes from multiple dates. I think it's a spread of 5 years or something like that. So this doesn't represent over a large area, this will represent several years. Google have produced something called the Environmental Insights Explorer. And again, this is free at a city scale for some cities that are already present on their Environmental Insights Explorer website. And if you're interested in other cities, they can be requested. But it's worth noting that the city boundaries they've used are not the same as local authority boundaries. And again, the data is derived from aerial imagery using a whole load of dates to give the best image. So the date for this baseline is unknown. We've got the tree equity map, which uses the Google data that we've just described. So the date for that is also unknown. We have the ward level urban tree canopy cover web map and data set produced by Forest Research. And that was a citizen science project, and it was great for engagement. And we're very confident about the date as the assessment, but once again, multiple dates of imagery underlie that method. And once again, we don't know the date of those images. And then finally, there's two sort of within app examples. So one is Tree Plotter Canopy. This is a tree canopy viewing and analysis platform. Canopy calculated in-house by a machine learned image classifier, and that's a paid for subscription. And then we have Tree Keeper, which is a tree inventory viewing platform. And the paid for subscription also includes canopy cover. So you can look at your individual tree records and the calculation of canopy cover. So those are data that already exists and that you can just grab and not need to process to understand canopy cover in your area. As well as that, as Dee mentioned, there are options for processing data to a limited extent or to running your own assessments. And what I will do here is skip straight to the bottom row, which is a do-it-yourself version of the iTree Canopy tool. And this is something that you can do for free in-house. It's time-consuming to do numerous geographical areas, but hopefully we'll demonstrate towards the end of this presentation that this might be, if you're going to need to measure change over time, a reliable way of doing that. And it's quite easy to do. You can do it in Google Earth, or you can do it in Esri, ArcMap, QGIS, and so on. And yeah, the other options that are here have the similar issues to the table that we've just described. So a brief note here about iTree Canopy and iTree Eco, because these sometimes cause confusion when we're talking about them. So iTree is a suite of tools from America. It's free to use. And iTree Canopy and iTree Eco are different tools within that suite. So iTree Canopy, which I've demonstrated with a made-up image on the top right there, is designed for measuring canopy cover and for very approximately estimating benefit provision. And it's an assessment that you do online. You're presented with an aerial image and you add random points within a boundary and you classify them as tree or not tree or other land cover classifications according to why you're doing the survey. In contrast, iTree Eco is a survey protocol and mathematical model designed to take a sample across a city with and without trees, and then extrapolate that data to represent tree populations across a whole city area, enabling a more realistic estimate of benefit provision. So they both give estimates for canopy cover, but I wouldn't generally recommend iTree Eco just as a canopy cover tool. That is not its main strength. And we usually find that iTree Eco underestimates compared to iTree Canopy. I've got a little note about data collection dates here. So this is a representation of some data from Blue Sky's National Tree Map. And they keep the data up to date by having a rolling program of data collection and analysis. But that means that the latest data that's available may not be from the same year. So that's Leeds on the left-hand side showing data for half the city from April 2020 and half the city from June 2020, which may not initially seem like too much of a problem. They're both from the same year. That's quite a tight time span as far as these things go. But if we compare June and April data, such as the figure on the right-hand side, what we find is that in April, the leaves are not fully out on the trees yet, and we miss entire trees that are actually still there. So the orange data on the right is from spring data collection, and the brown data is from summer. And we went outside and checked, and the trees that are circled are very much still there. So it's not that we've lost canopy. And if you're relying directly on that data, I think that could be quite misleading. I'm not meaning to pull out or criticize individual methods or techniques. It's just a sort of awareness raising exercise that you have to understand the data that you're working with. So often what we want to do with canopy cover assessments is either, or both of these, make a baseline so that we know what we've got and we can make decisions from there. And then we may want to measure change. So if we plant a load of trees, we may want to know in 10 years whether we've been successful at increasing canopy cover. So a baseline is an initial measurement against which we can measure change. And to reliably measure change, we have to use the same or a closely compatible or comparable technique. We have to either measure at exactly the same scale or be comfortable at converting between scales. So if you've got ward level data and you want to look at a whole city, you must be comfortable doing that calculation. We have to be using the same boundaries, or again, have a means of calculating information about the same boundaries. We must know the dates of the baseline and of the new assessment, even if that's two date ranges that hopefully don't overlap. We still must know them so that we know exactly what we're dealing with. We have to understand and take account of method or imagery changes. And in particular, we have to be careful with precision. So if you're seeing a difference in numbers over years, is it statistically significant, or are those numbers actually the same within their errors? And two key points, which I'll stress again: most newly planted trees will not appear on canopy cover assessments for many years. They're just not big enough to be detected either by the automatic methods or by a lot of human eyes if you're looking at aerial imagery. And secondly, if we're going to plan or measure the success of canopy cover increases, we have to be aware of what the underlying trend is in our canopy cover. If it's declining, our planting needs to exceed the rate of that decline in order for us to have the effect that we want. Some examples then of how canopy cover has been used in different situations. So this is a paper by Doig et al. From 2020, in which they used historical aerial images of the same area using the same technique to calculate canopy cover over a number of years. And the reason that this worked is that they had a clear aim. They knew exactly what they wanted to do with the data. They knew the individual dates for each image. They used the same method on each image, and they kept the boundary the same. And I've included a quote here as a sort of conclusion from the paper, and it says, "Over the past 2 decades, however, the trends are more variable, with 6 towns displaying no statistically significant change, 1 declining, and just 3 increasing in canopy cover." And the reason that I've chosen that is to demonstrate that until we measure it, we don't really know what's going on in our individual area. So we have to have a good understanding of that really before we start on anything else. This is a slightly less successful example, and one which many of you may be familiar with. So in 2019, Bristol launched their One City plan, and within that they aimed for a 25% increase in canopy cover by 2036 and doubling of canopy cover by 2046, but they didn't quote a baseline. After that report was produced, several baselines varying between 8% and 18% were published. And it seems that they've now accepted the 18% as their baseline, which means that their target is now 36% rather than 24%, which is a big difference. And a great example of canopy cover use in combination with different data is what Birmingham tree people have done with their Tree Plotter account. So this is a free to view map, and you can, on the left, you can change these priorities such as health, tree equity, low canopy, and areas where you could possibly plant trees to produce this coloured map on the left with priority planting sites shown in red and less priority areas shown in green. Again, they've gone with a single source of canopy cover data. They've kept the boundaries consistent between different data sets, and they're not just using canopy cover to inform their decisions. So some concluding thoughts. Canopy cover has the potential to be really useful, but we need to be aware of what the data really means and what the pitfalls and challenges are around it and what it can and cannot tell us. As we've seen with most available data and methods, it's really hard to know the date that it represents, and so it's difficult to measure meaningful change from that baseline. And in that sense, the DIY approach, where you know the date of the imagery, might be the best approach at the moment. And finally, canopy cover does not tell us everything. It needs to be combined with other data for it to be really powerful. Thank you very much.
Right. Thank you very much, Hannah. That was excellent. A real deep dive into the challenges that we've got with our canopy cover management options. So are there any questions that people would like to put to Hannah immediately? I think, Sue, you had one or two.
Mark Serrett had a question. Has anyone overlaid canopy cover mapping with surface water flow maps to show potential for dual flood reduction and tree benefits as a way of justifying expenditure? Emma's partially answered it, but does anybody have anything to add to that? No, right?
Not yet.
Just that it's very simple to do in GIS, and Tree Plotter is a great software because it does all of it for you. But if you have a little bit of GIS, and sorry if there's anybody from Tree Plotter on the line, you could do it yourself.
My own question was that, for those of us who aren't expert, how do we and I know we did that mapping workshop, and I know there's massive, how do we decide, what to use and what level of confidence should we be hoping to get as a result of which method we choose to use?
In terms of level of confidence, that will be a combination of the accuracy and or precision reported by whoever's provided the data or built the method, and the elements that we've just looked at. So if your underlying imagery spans, for example, 2016 to 2022, you're going to have to say that in whatever you report. So you don't then have a baseline for 2022, you've got it for that range of dates. So it's a combination. And I think just having these kind of conversations, talking to people, comparing what other people are using will be helpful, and really getting data providers to be crystal clear about what their data represents and how it was gathered will be a huge step forward.
Which I seem to be asking lots of questions here. So my other one, it really worries me. Your Bristol reminded me of that you might set a target, we want 36% or 25% or whatever. But then the reality is you've got to have the space on the ground to put the trees. And then at what point are you saying this is when the target will be achieved, plus 30 years, plus when? Yeah,
it's really tricky. So I think there's something to be said for really ambitious canopy cover targets. And then if you miss them, you've still made a huge difference. So it depends on whether an organisation or a local authority is holding themselves to that exact number, or whether they're giving themselves that target to just be really ambitious. And I think both are acceptable approaches. If you are aiming to get a number, then yeah, you definitely have to know that you've got space to plant, and you're going to have a lot of private landowners on board to do that.
Do you see anything else, John? Just one at the bottom, but I think perhaps we come back to that as part of the more general discussion.
Yes. And actually, your last question is a really good link to our next speaker. So if I could, I would like to introduce Luke Fay, Managing Director of Tree Work Environmental Practice, who's going to talk about how to predict canopy cover, first steps in the guide part 2. So over to you, Luke.
This and this. Right. Let's see. Are you seeing the presentation or my speaker notes?
I can just see you.
See me? Can you see the presentation?
Not yet.
Just you, Luke.
Okay. Share screen. I don't have screen sharing abilities.
If you look at the Zoom interface, Luke, at the bottom you have audio, video, chat, participants, react, and then there should be a green arrow for share and up.
Yeah, just press it. It says host disabled participant screen sharing.
Deanne, can you enable screen share, please?
Sorry, yes, it's
Someone
because
with
I
greater
think you got
competence
kicked
than
out
me.
and came back in, and I didn't make you co-host. It should be there now.
Do you want to try again, please, Luke?
Yeah. Here we go. And I'm going to, I think it's this one I need to share. Right. What can you see?
You at the moment.
Okay. Okay. Yeah. Sure.
We're off, Luke.
Yeah.
Things are starting to happen.
Yay.
We have your, that's
Yep.
it. Perfect.
Yeah. Okay. All right. So I'm going to crack on. Good afternoon, everyone. Thanks for the introduction, John. I only have 15 minutes. I've wasted quite a bit of it already. I've been asked to talk about how accurately can we predict canopy cover projects and what uncertainties and how much does accuracy matter. That's a long title, so I've used up quite a bit more of my time now. I have 3 messages I'm going to try and get across. Firstly, is it accuracy or precision we're talking about? I'll come back to that. Then first message, we're modeling, we're not predicting. I think that's going to come across in the talk. Secondly, we need further study to enable better modeling, more precise modeling. And thirdly, models are great, but if we do not provide the environment where trees can flourish, then what's the point? The practical outcome is really what matters most. I'm going to touch on scientific stuff, but I'm not a scientist, so feel free to correct me in the chat if I confuse terms like accuracy and precision or complex and complicated. I won't see your comments, but it'll make you feel better. Okay, so what do we want to achieve? We want to achieve a plan, because we want to be able to plan for, quantify, and communicate the results of tree retention, removal, and planting over time. Canopy cover is an excellent metric for this, as has been mentioned before. And I think this is mainly because there's an immediacy to our experience of it, its effects on our environment, visual amenity, shade, etc. It grows with the tree, and we can present it clearly in 2 dimensions or 3 dimensions. In this regard, canopy is a good proxy for the value and benefits that trees provide. It's been adopted by many local authorities. We're going to hear from a couple of them later, and been used widely for in various analysis we already heard, and it has been suggested as a proxy for value by the emerging revised BS 5837 and recognized and explored in the TDAG documents and guidance, some of which we've heard of today. However, we need to be clear. We're talking about models, but we're not in the business of prediction. I've heard it's very difficult to predict, particularly in relation to the future. So models don't predict, they illustrate a likely outcome. And we must be clear about the variables and parameters, as Hannah was just talking about, that result in the outcome that we present. Okay. So why is it difficult to produce these models? So think of a tree. Now, I didn't do a poll for this, so please just all put in the chat the species of tree you thought of and its life stage. I won't see it, but I think we'll see some patterns emerging about how we consider trees when we think of them straight off. So And that just reflects a little on why it's difficult to model tree growth and canopy growth, particularly over time, because we're trying to create standard models and terms for ridiculously complex organisms that exist in 3 and 4 dimensions beyond the scope of any of our lifetimes. There are a ridiculous number of variables which can be grouped into, I think, 3 main factors. Genetics, that includes species, the environment, so the growing conditions, etc., and stuff that happens. That would probably include management, storm damage. I think if you take out the environment bit, all of these things affect the rate of growth, the extent of growth of the canopies of trees. And so we could list a whole heap more variables, including when it comes to environment, the rooting conditions, etc., shade, these kinds of things. But I think I made the point, and I think you all get the principle. And I've put up some images here of different crown forms, tree growth over time, and morphology, which I think illustrates some of the issues that we come up against. Also, there's the practical difficulty of modeling, for instance, large populations over time. I have some project models with thousands of rows of data, each representing a different tree, different species of tree, maybe different size at the time that it was measured originally. And it can be incredibly complicated to implement any changes, to audit. And if we, for instance, do a ground truthing audit, it can take days and days to go through each line of data and make sure that no errors have been made. So I'd say the more variables we add in, the more complicated the model is, the more data is in it, the more prone to errors the process becomes. So there's a lot to be said for keeping it simple. So what resources do we have to help us with this type of modeling? So I think probably I made a mistake by not differentiating the type of modeling that I'm talking about from what Hannah's already talked about. I'm talking about capturing data on existing trees and proposed trees, and then using that information, measured information from site, to model growth into the future. Yeah. So we have an increasing number of resources to hand, including the various works by Madalena Vaz Monteiro, Hannah Walker, Kieran Doig at Forest Research on tree allometry. The papers are online and referenced in the guides from TDAG. Also, there's another paper on tree allometry by Andrew Coombs, Jane Martin, and Duncan Slater, also referenced in the TDAG documents. Kenton Rogers and Tree Canopy have been doing great work in this. I really need to give a shout out to Sharon Durden Hollenby, Sharon Hosgood Associates. Sharon's championed modeling canopy cover within the planning context for years and years. And recently, just December last year, I've been working with Joseph Fennell and the Open University on analysing thousands of records of tree data captured over many years of measured surveys, BS 5837 surveys mainly, provided by us at TreeWorks, but also provided by 10 other providers, including councils and forest research, as well as other consultancy practices. And we've produced a handbook called the Handbook of UK Urban Tree Allometric Equations and size characteristics. And this has 46 different species, UK species, 29 genera, and it provides allometric relationships for the measured parts of the trees, the stem height, sorry, the tree height, the crown spread, and the stem diameter, DBH. And it gives the 95th percentile of it's the most frequent, largest measurements for mature trees or trees within the mature life stage. And so it has thousands of records, but there are still gaps there. For instance, we've got over 1,008 Quercus roba represented within the book, which is great, but only 21 Acer saccharinum. So you can see that, as we'll come on to later, there are issues with some areas of precision, or greater issues with some areas of precision than there are with others. But these are great resources. There's also a lovely, excellent article in this the current ARB-mag from a consultant called Mr. Underwood, and I recommend looking at that. And there's also the individual tree data standard, which TreeWork produced with Open University and Forest Research. And the document I'm always going back to for this this type of modeling is John White's Measuring Trees document. And the way we've applied that is by modeling stem diameter growth over time. And we can then apply the allometric models to the allometric relationships, sorry, to generate canopy spread from that. So, and I need to give a shout out to Paul Muir in TreeWork, who has done all the Excel work on our growth model for using John White. And so, yeah, if we know the rates of incremental stem growth, and John White has broken that down to into the core age, the average annual increment, which is where the tree moves into its mature phase, where it's putting on the same area of stem increment rather than the same ring width of stem increment, and then on into senescence, where it's much reduced or maybe even zero in terms of growth. So we can then model the allometric relationships from that. And so from that, well, from the work that Joe Fennell and I have done together, Joe's produced this spatial software, which also adds in some of those parameters that we talked about earlier that may restrict crown growth. And like other trees or buildings, etc. And from this, you can see this is over 50 years. It shows tree growth, canopy growth over time by using the allometric relationships and applying them to a spatial software. So this is one of the ways that that we can model growth over canopy growth over time by applying these allometric relationships to some known factors. And we need to consider the obstacles to growth, as I mentioned before. So, you know, in the guidance from TDAG, it's very clear that we shouldn't be double counting, for instance, canopies that overlap one another. So you need to, it really needs to be presented spatially. Otherwise, it's very difficult. Well, otherwise you're not getting the accurate canopy cover. So accuracy versus precision. Hannah have kindly provided me with a link to this image here, which explains it well, I think. And I think if everything is measured at the time that it's measured, I think at that point we could say the model is accurate. But then accuracy will reduce as the model, as time goes on. We could potentially increase accuracy by applying more of the variables to each tree. But for larger populations, precision will be more easily achievable. Audits and applying the learnings from audits, that is going out and measuring the outcomes, will help future models. But precision matters for the confidence that we can have in our models to help with planning and decision making. But it would be brilliantly optimistic to expect to deliver an accurate outcome over 30 years. However, as Hannah mentioned earlier, you could build in redundancy. So what else? Well, I think I've illustrated that we need more information and more study. And the arboricultural profession has a massive wealth of measured tree information. And if we could pool that, as we did, some of which we did already with Open University, and devise a good study project, we could learn a tremendous amount more that we could apply to future models. So more data, more study, and let's model good growth, but let's also deliver good tree growth. Outcomes still matter. Thank you.
Brilliant. Thank you, Faye. Thank you, Faye. Thank you, Luke. Mr. Faye. That was excellent. Just, I don't know if you spotted on the answer to your question, the trees coming through were, on the one hand, well known, but all very old and large. And then we started to get through some sort of a couple of younger examples. But I think you made your point. We all think of a very kind of large established tree is what jumps into our heads. So
am I sharing still, or have I stopped sharing?
You're sharing still.
Oh, here we go. I found it. Okay, so yeah, my competence in Zoom is even less than my competence.
The least important aspect. Yeah, really, really interesting messages. So we had a couple of questions pop up, not fully into the detail, but a couple of interesting angles. Got one from Andy Sherville. Did you want to ask it directly, Andy? If you want to if you're happy to turn your screen on, or I can do so on your behalf. Can't see you, so I shall do so. Right, on a development site level, is there a conflict between canopy cover targets and BNG requirements? Can we achieve both? Rarely see an increase in canopy cover, and asking the developer to show this seems quite difficult. Can you comment to that?
I mean, I guess there could be a conflict. I mean, I think there's so many conflicts between good arboriculture and BNG as led by the metrics, and canopy cover could be, for instance, it's an example that people are probably bored of me running out, but you get much better BNG for a pond or for a load of blackthorn than you would do for keeping a cherry tree on site or something. So yes, so there would be conflicts, but I think it's just one of many.
And I've had another one from Harry Bisht. Happy to put it to the group if you wish. And that's, can the allometric equations help us in predicting carbon sequestration capacities of tree canopy?
Yes, is the answer. I mean, I'm assuming that I believe iTree will be using allometric equations. John, you know this better than I do already. So yes, is the answer.
Yeah, that would be my sense. It's actually, I think the difficult bit is predicting the tree growth per se. If you are confident about the numbers you've come up on that side, converting them to carbon is relatively simple. The challenging bit is working out how big the tree is going to be at some theoretical point in the future.
John, I saw one from Fiona Melville about could this assist in biodiversity quantification for individual trees. I know that in Scotland they're really looking at what their metric should be and how to improve perhaps on the English metric. So is that a sort of I don't know if you're there, Fiona, but is that a useful, is there a link there? Luke, Hannah, anybody?
Would you read the question again, please?
Yeah,
Sue?
could this assist in biodiversity quantification for individual trees? Accuracy of canopy cover.
I think tree volume might be a better measure for so many things. In terms of hosting habitat and food, I think tree volume would be a better metric, as would veteran and ancient features, I think. But Luke knows more about that than I do.
Yeah. Yeah, I mean, there's lots that goes into biodiversity, isn't there? I think as Hannah just said, the saprozylic element is really key. Hi, Fiona.
Hiya. Yeah, I just asked the question, obviously, crown volume, and we've been looking at the Italian research that was presented by Claudia Canadoli at the ARB conference in September, and tree-related microhabitats, the Shannon-Viner index. You know, do we use crown volume? Can we use crown volume? At the moment, the current metric uses area. So crown spread might be a substitute for that. And we realise it's a blunt tool, but the Canadoli research confirms that crown volume is a much better indicator of biodiversity. So we're obviously thinking about this up here and hoping that we get it right somehow or another.
So it's another new metric. It's quite interesting. The Dutch are just in the process of adopting crown volume as a mechanism, because they recognise, exactly as you're talking to, that the two-dimensional is a very thin way of looking at the whole story. And so they're talking about cubic meters per meter of ground area. So
that's fascinating, John.
Yeah.
Could you send a link to that? Is that possible?
I will find a way to send a link to that.
Superb. That's great. Thank you so much. Thank you.
Yeah. So everybody's playing with this. Countries all over the place are trying to wrestle with the challenges that we've put ourselves through, today. So they've gone down that road. But as you can imagine, it adds another dimension to exactly the same problem. How do you do it in a way that's accurate, precise, repeatable, that we can trust and make decisions from?
And it's another allometric relationship then, the crown, the height, the difference between the bottom of the crown and the top of the crown, if you like.
Yeah.
To be considered, and that's an area that's that is, well, in urban setting is managed, because tree crowns are raised to make access. Could I just mention, because I didn't properly accredit, Matt Underwood wrote the article in the ARB mag, this current ARB mag on canopy cover.
Right, thank you very much. Okay, I'm going to move to our next speaker now so that we can stay approximately on time. Our next two speakers are now going to move from the theory into the practice, and they'll focus on that aspect. And first, I'd like to welcome Chris Leyland, who is Tree Officer at Oxford City Council. So over to you, Chris.
Thank you, John. I'm going to try and share my screen now. Let's see if I can manage that. Can you just let me know what screen
Well,
you're
I'm
sharing?
sharing already. We've got your cover slide.
Okay, that's great. Okay, so hello everyone. My name's Chris Leyland. I'm Senior Tree Officer at Oxford City Council. And Oxford City Council is responsible for trees as the local planning authority and as a major asset holder of housing sites, parks, cemeteries and allotments. Oxford is a historic and heritage-rich city, famous for its university. It has a population of 160,000 over 46 square kilometres. So it's small and geographically hemmed in by the floodplain of the River Thames and Cherwell. As well as the obvious wealth of the city, there are also pockets of significant social deprivation. Oxford is an international centre for science, R&D and healthcare research. Therefore, it is a city with a big growth agenda, meaning development. At the same time, the City Council has declared a climate emergency and an emergency response across its services. So that's the context. I'm here to talk about Oxford's use of canopy cover assessments, both strategic, i.e. at the urban forest level, and at the local or site level related to development. Starting with the strategic, the urban forest, what is that? The definition we have is Oxford's urban forest comprises all of the trees and woody vegetation in the city, located across a range of land ownerships, and which provide ecosystem services, habitats, and benefits to human health and well-being. So how do we manage Oxford's urban forest to maximise these social, environmental, and economic benefits? Well, it remains a key touchstone, I think, in this. Trees and Towns 2, published by the Department of Communities and Local Government back in 2008, Mark Johnson, quoting from that, a comprehensive tree strategy is the starting point for a modern planned approach to tree management. That strategy must also be integrated and embedded into the local authority's local plan and other relevant policies. So next, I'm going to go on to tell you about how Oxford's great strategic approach to forest management is and how canopy cover assessment underpins this approach. In truth, it's still a work in progress. The main elements are in place, but there are still significant challenges around the council's corporate structure and buy-in among its stakeholders, both external and internal. Pressing on, we have three principal mechanisms for delivering strategic management, each of which to a varying degrees are informed by canopy cover assessments of different types. We have our Oxford Local Plan 2036, which sets the spatial and development management policies. Development management, it controls development, and also a planning function, although not part of the local plan, is trees and conservation areas and TPOs are a planning function. Now, the tree management policy sets the council's own policies for managing its own tree stock. That includes the planting plan policies, tree risk zoning, survey intervals, and responses to complaints and claims, etc. Now, ideally, as an overarching structure, we have the Oxford Urban Forest Strategy, which sets the vision and urban forest canopy targets for the city. It coordinates urban forest stakeholder activity and seeks to engage and influence stakeholder behaviours. And the text in green indicates those elements which are strongly supported by canopy cover assessments. Now, I've already alluded to the different canopy cover assessment typologies, which are at the strategic level, country, region, city, which is Hannah was talking about earlier. And then there's at the local or site level, which is really about scenario modelling for development, which is what Luke was talking about. Now, canopy cover assessment, what is that? I think we've heard it already. It's a quantification expressed as a percentage of the 2D or plan view of the tree cover in an urban space. including other woody vegetation, depending on the scope of your assessment and the facilities of your method. So back to canopy cover assessment at the strategic level. Why do we do it? Well, land management requires geospatial data. Basically, the canopy needs mapping. It's necessary for apportioning resources and budgets in proportion to the asset's size and its complexity. It's needed for monitoring and managing the asset, to manipulate its size and composition, providing that you have additional ground sources of data at a more granular level. And canopy cover is a simple proxy metric for quantifying ecosystem services and human benefits. Put simply or simplistically, more canopy cover equals more benefits, assuming it's the right tree in the right place, etc. So we used Tree Canopy for our baseline assessment at the strategic level in 2015. And data can be stratified according to ward boundaries and LSOAs, also by land typology. And here on this slide, you can see that we've got treescape, different types of treescape identified, public parks, open spaces, residential gardens, allotments and community orchards, linear routes such as railways, woodlands, graveyards, street trees, and institutional grounds. It's really useful to be able to know how the urban forest is distributed in that sense. Looking at the canopy cover of Oxford on the ward level, you can see here on this slide that there's quite a distribution in canopy cover across the city, from 11% to nearly 30%. And it's only when you compare that with the geographical factors, which you can see that the Jericho and Oseney ward, which is that bit in the top left, is explicable by the fact that it's actually floodplain and it's covered by a lot of grazing land. And the bit to the right of the river, I don't actually know whether you can see my cursor or not.
Yeah.
You can. Okay. Well, this area here is called Port Meadow, and it's a triple SI. So basically, none of this area is really suitable for large-scale tree planting, and it contrasts with the Cowley ward and the Lyve Valley ward to the southeast of the city, which have similar low levels of canopy cover, but don't have any of the same geographical factors of constraint. And they, in fact, have similar urban grains as areas to the north of the city, northeast of the city, such as the Headington and Quarry and Risinghurst wards, which have very high levels of canopy cover. So Oxford has a bit of a tree equity problem, really. Overall, Oxford compares quite favourably to other UK cities. It's got 16% tree cover, or 21% if you include all other woody vegetation to that. But as I've mentioned, there's a tree equity problem. Drilling down into that a bit, you can see this overlay of index of multiple deprivation, which is at the LSOA level. And we found a strong correlation between areas of high deprivation and low canopy cover, which immediately provides some important information for prioritizing where to focus tree planting efforts. Okay, so moving on, canopy cover assessment for development. So this is at the local or site level. The slide here is quite a simple example, but demonstrates some of the aspects of visual presentation of a study. You can see existing trees which have been retained. These are semi-mature trees, so they've showing increments, which are shown by these radial increases, which are at 10, 20, and 30-year increments. If the trees had been mature, it might have been appropriate to essentially assume no further canopy growth or canopy spread. And then here we've got young trees that have been planted as proposals for compensation. So this is essentially the compensation aspect of the scheme. So it's a study essentially that models canopy dynamics in the context of development, and it can be a feasibility exercise or a study required by local planning policy, as in Oxford, in relation to a planning application. It provides a method for comparing a development scenario against a no development scenario, therefore demonstrating the impacts of proposed development on existing canopy cover over time. It's, as Luke has stressed, it's a modelling exercise and its limitations for prediction must be recognised. In Oxford, such a study is a planning requirement on any major planning application site. And how have we managed that? How do we require that? Because it's embedded in the local plan and it's supporting planning documents. So the next slide is just an extract from our local plan, policy G7. Policy protection of existing green infrastructure features. The policy recognises the value of trees as part of green infrastructure. It sets a hierarchy test. Tree retention is obviously the goal, but where trees are shown to be not retainable, there's a feasibility test for that. Compensation by new trees is a requirement. And here's the key point: with consideration for predicted, sorry about that, Luke, it's in the text that was produced previously, and the next local plan will say modelled future tree canopy following development. So that's how tree canopy cover assessments plug into our local plan and how we can require them. So a canopy cover assessment provides a means to assess the implications of development, both immediately and over time, including assessing the compensation measures evaluated in spatial terms. And this is an invaluable tool in assessing sustainability in the context of the NPPF presumption in favour of sustainable development. Now, giving flesh to the bones of policy G7, we have a technical advice note on green spaces, TAN 9. TAN 9 carries significant weight in assessing compliance with policy G7. One caveat to that is that it actually hasn't been tested at an appeal yet, but nevertheless, it's being used. This is an extract from the soon-to-be-published second edition, which for the first time will set out canopy targets for acceptable development. Acceptable is no net loss. Sorry, let me just go back to the actual slide. This is a matrix that shows types of planning application that the tree canopy cover assessment applies to and examples of compensation that should be targeted where necessary. So acceptable is no net loss or an increase in canopy cover to a target percentage at 30 years post-development, whichever is the greater. And these are set at 15 or 20% targets, depending on the size of the site. So if it's less than 15%, then the expectation will be that it will increase to 15% or more on those suitable sites. Or if it's already over 15%, then there should be no net loss. And the TAN also sets out some parameters for canopy cover assessments, the methodologies for them. The basics of this are that first, the baseline canopy cover is calculated, and the British 5837 tree survey will inform this. Then the pattern of tree canopy increase, stasis or loss, think of useful life expectancies, is modelled over time at 10, 20 and 30 years. This is the no development scenario. An alternative scenario involving development is modelled from the baseline, which factors in tree removal due to development and the future canopy increases of retained trees and new trees planted as part of landscaping. One can be subtracted from the other to give you net results. And it's worth noting that these limited parameters, the guidance on them has actually yielded some really quite comparable canopy cover assessments from different landscape architects and arboricultural consultants. And often arboricultural consultants work with landscape architects because they're really used to using the GIS tools that this sort of exercise really requires. So just finally, just the current state of play with Oxford is that we have our Oxford Urban Forest Strategy. We're going to repeat our canopy cover 10 years on from the 2015 baseline. Thanks to the County Council for that. And we hope to have a Oxford Urban Forest Strategy Coordinator soon to implement an overdue action plan with canopy targets and detailed planting programs at its heart. And that's it. Thank you very much.
Thank you, Chris. That was excellent. Really, really, really interesting, and very impressive to see that on policy G9, policy G7 and TAN's G9, I'm very impressed with the fact that you've embedded it in. We have a question from, well, Sue, can I read your question out? Do you want to read your last one out? Because I think that's very...
Yes, go ahead. Go ahead.
So, Chris, how have developers received this? Have they been positive about delivering on these policies?
Yes, they have actually. I mean, I don't know whether sometimes I have to pinch myself and think we live in a bit of a bubble in Oxford. There's a lot of high quality development and high end landscape architects and architects that are involved in the schemes that we work on. And in general, I think people have really taken to it as, quite an exciting new enterprise, really.
Good. I'm going to borrow it and show it off to others. Really, really good. You're still sharing your screen, by the way.
Okay, well, that's the next challenge.
Just another one. Have I got a new one in there? Yeah. Do David, would you like to ask directly? David Busfield. Everybody's willing to turn their screen on. Right.
Has my screen stopped sharing, by the way?
Yes.
Right.
Now,
I think somebody else might have done that for me.
If you put your camera on while you're still speaking, that would be great. One from David: do canopy cover assessments get confused by other types of vegetation? And can they be expanded to cover a more sort of overarching urban nature loss gain kind of concept assessment?
Well, we've got to remember that we've got BNG as a backstop to all of this. And also we are toying with this urban greening factor tool as well, which I can't really speak to in detail at the moment, but essentially those tools, I think, capture those other elements in a better way than the tree canopy cover assessments can do, which, let's face it, it's complicated enough as it is already.
Yes. Thank you for that. I agree. We've got a plethora of tools coming through. The fact you've made this one work and underpins the stuff you've done is excellent. I actually quite impressed that you found common ground for the ARBs and the landscape architects to come together. So that's equally very powerful. Thank you very much for that. Are there any more questions to come through?
I don't think any. I mean,
right. In which case, let us move on, and we can now turn to James Gregory, Tree Officer for Cornwall, who will give us an update on delivering practice and its impact in that county. So over to you, James.
Hello, I'm guessing my screen is sharing.
Perfect. Already happened.
Excellent. Okay, so I'm James Gregory. I'm Tree Officer at Cornwall Council. And we have the canopy calculator. I'm just going to give you a quick overview of that. Cornwall Council canopy calculator forms part of the Cornwall Council Climate Emergency DPD as policy G3. Cornwall Council declared a climate and ecological emergency on the 22nd of January 2019, and the DPD is the responsive planning to this. The DPD was adopted in February 2023, and there are a range of policies from coastal management, sustainable construction and town centres. And the canopy policy forms part of the natural climate solutions section, which consists of green infrastructure, biodiversity net gain, canopy and local nature recovery. Canopy policy became a validation requirement on planning applications on the 15th of June 2023. Quick overview. We adapted a working calculator from High Wycombe for Cornwall. It brings best practice into the planning policy, more weight for trees in the planning process, gives arboricultural matters earlier consideration and development, and gives a clear benchmark and a level playing field for all applications. It prioritises the retention of existing canopy, provides minimum levels of canopy provision, and helps to build in climate resilience when considering species choice. So policy G3 reads, all major developments should provide, through the retention of existing and or the establishment of new canopy, coverage equal to that of 15% of the site area, in accordance with the Cornwall Council approved metric. How did we arrive at 15%? 15% is recommended for coastal areas by the Urban Forestry and Woodland Advisory Committee. Existing parish averages within Cornwall is around 10%, and it is an achievable minimum figure and will drive up delivery on low performing sites. What would we consider canopy? Individual trees, groups and arrangements of trees, existing native hedgerows, including those atop of Cornish hedge, new native hedgerows within the public realm, selected scrub, and all woodland habitats. What we do not consider as canopy would be limited wooding scrub, non-native shrubs or hedgerows, hedgerows not within the public realm, i.e. domestic garden borders, and green walls and roofs. Paragraph 1 of the policy. Any proposals to remove canopy on the site should be justified in accordance with the mitigation hierarchy, so avoid harm, reduce harm, or restore. Paragraph 2, where there is existing site canopy is above 15%. Where a pre-development site already contains canopy that exceeds the 15% requirement, the development proposal should ensure that retention of as much canopy as possible on site in line with the mitigation hierarchy and should justify any losses proposed. An alternative canopy cover percentage, as evidenced by the approved metric, should be agreed with the local authority. Where we have less than 15% outcomes, where there is significant ecological, historical, landscape, or operational reasons to justify a canopy requirement of less than 15% on site, this must be fully evidenced and an alternative percentage canopy provision shall be agreed with the council. So examples of where 15% might not be appropriate, where there's significant impact on heritage assets, significant impact on a designed landscape or designated landscape even, solar farms or aviation sites where canopy would conflict with site usage, ecological reasons where there'd be a significant impact on the balance of net gain where it would be disproportionate to canopy, where it affects the provision of the 10% net gain on site, or where it would have an effect on priority protected habitats, rare or protected species. Minor developments are not required to demonstrate the 15% canopy target, but they should explore all options in relation to canopy provision and take appropriate measures to both avoid and reduce harm to existing trees on site, and where appropriate and practicable, provide new canopy. With regards to new canopy should provide a mix of species that are resilient to pests and diseases and climate change, and should be delivered in sustainable locations in a manner that supports the growth and spatial requirements of the canopy. New canopy should positively contribute to climate resilience of the site in a manner which protects and enhances the existing canopy. So just a quick example of what we would see on an application that came in. This is a pre-development site. We have some off-site trees with overhanging canopy. We have some boundary hedgerows. We have some on-site trees, some trees on the boundary, some scrub habitat, and a gas line running through the site. So only canopy that is retained or established within the application site is counted as canopy when you're doing your calculations. So here's, for example, T6 originates outside the site but overhangs inside the site. This would not count as canopy provision. T4, T5 and H5 originate within the site, but some of the canopy overhangs outside the site. Overhang outside the site will need to be deducted. If the red line boundary exceeds the area of the applicant's influence or control, or if the area is for future development, and only the area within the current application influence is to be counted. So here's an example post-development of the site. We have the retained boundary hedgerows with the deductions. We have the retained boundary trees with the deductions. We have some retained internal hedgerows, some new internal hedgerows, some new tree groups, some new scrub habitat, some new garden trees, some new street trees, and retained trees with pruning that was there to facilitate the development. So usage of the canopy calculator, it's to be operated by our professionals, ecologists or landscape architects. It's an Excel document. It measures canopy above ground, not root protection area. It contains figures for average canopy spread of the majority of tree species, measures tree groupings, and it calculates the canopy spread at 25 years to be shown on a projected canopy plan. Just a quick overview of the spreadsheet. Starts off with a site summary. This is the first key sheet for use in submissions and will be used for initial assessments. Initial data will be application site area, priority habitat areas for deduction, and other areas for deduction, e.g. utilities. We then move on to the retained canopy sheet. This data can be extrapolated from BS 5837 surveys and ecological surveys. Cardinal points can be used, or the data can be taken from CAD and populated manually. We subtract the areas of site overhang, overlap, and proposed remedial works, and data from this sheet updates the site summary page with the required data. We then move on to new canopy. Our consultants will work with landscape architects and will help inform the landscaping scheme. It populates canopy at a point of planting for larger trees, groups, and hedges, provides a running total at the top of the page, and once again it updates the site summary page. We have a species list here. This is predominantly for reference and selecting species suitable to the location. Some of the data comes from the Trees and Design Action Group species publication. We also have Cornish trees distinctiveness, and we have this here because Cornwall has a unique climate in the United Kingdom with a number of environmental challenges. Suitability and environmental tolerances to the location is important. This will help identify species which are more likely to establish and provide long-term contributions within the Cornish climate. With regard to distinctiveness, much of Cornwall has identifiable, unique tree landscape. When designing planting schemes, this will require consideration for suitability and setting to include such matters as how regularly these species are found, whether they're indigenous or not, and will they positively contribute to the landscape character of an area. So the data is extrapolated from a number of sources, some from environmental tolerances, trees selections for green infrastructure as published by TDAG, and growth canopy values and growth rates from the Hilliers Tree Guide, both of which can be found online. So what would this mean for the planning process? It gives explicit recognition at local policy level. It gives clear minimum expectations, early consideration of canopy, increased liaison, and some additional submission documents. What will it secure for residents and communities? Greener sites, shaded streets, improved air quality and reduced flooding, improved mental well-being, increased carbon sequestration, wildlife on the doorsteps and in workplaces, and increased property values. What does it mean for the developers? Explicit recognition at local policy level of the value of canopy, clear minimum expectations for canopy provision, a need for earlier consideration of canopy and the constraints and opportunities, increased liaison with their project team and consultants, and the need to submit some additional documentation. What will it mean for consultants? Earlier commissions, clear expectations and guidance to respond to, need to be mindful of ecology and survey data, greater liaison between green sector consultants, and support in obtaining new plantings. With regards to tree officers, it gives clear canopy provision requirements and supporting policy, earlier consideration of trees, spatial conflicts, 2 additional documents to review at consultation, and improved pre-commencement planning conditions. So the policy has been in effect for more than 18 months now. We've had a number of submissions of varying qualities. This will be as the private sector is getting used to it. Some of the common issues we've received: not all the documents are submitted. Linear groups and features which have reduced canopy value due to canopy overlap and not being specified so regularly. Red line boundaries are being amended to increase existing retained canopy on site. Some species are being selected for their 25-year growth potential to make it easier to achieve targets, which is having a negative effect on the right tree, right place. And in some cases, canopy overhangs are not being deducted. Is there any questions, technical questions, please do give me an email. And there's my email address.
Brilliant.
Thank you.
Thank you very much, James. If you're able to, would you be able to turn on your camera?
I don't have a working camera.
Okay, fine. We do have a few questions, so I'll Mark
I'm not sure
Siri.
how to stop sharing, unfortunately. Can someone stop me from sharing?
Yeah, I'll ask it. So James, I work in planning consenting within the local flood authority, and this is fundamentally the principle we use for managing flood risk site by site planning application. So we know it works, the leverage is there. But how do you allow for ash dieback and other potential, even unknown or on the horizon threats when you're doing these calculations? If you're setting a minimum amount and then they get hit in a period that you're measuring, presumably they've got to replant or something. I just want to see how you were modelling that, because at the moment we're going backwards faster than we're going forwards. So I just thought it was worth asking.
No, I understand that. It's difficult. So the new plantings are covered under the BNG requirements. So that's how we would protect trees going in. But with regards to incoming pests and diseases, we're mostly reliant on having a good diversity of species in order to maintain canopy cover. It's difficult. We do have an increase in pests and diseases coming in with climate change and international trade. Certainly, any failures within the first 5 years would be covered by planning conditions, but it's very difficult to predict which we will be losing and what we won't.
In the same vein, Sue, you had a similar question about taking account of just sort of any kind of mortality figure or survival rates, given you're operating on a 25-year timescale within the sort of modelling.
I've been looking at that, and somebody said, oh, but we'll just replant. But actually, we have such a performance gap with planting and survival on the whole. How do we factor in that we're likely to achieve what we hope to achieve?
Yeah, once again, it's something that we hope that with a decent diversity of species, we retain some of the canopy. With diversification is the key, as we all know, on particularly urban planting, but on all plantings. So different species, different resilience to different pests and diseases. We just have to accept that we are going to lose some of those trees potentially to influx of pests and diseases.
Okay, Jeremy, you had a question. Jeremy Barrell, if you want to put that.
Yep. Thanks very much. I think, first of all, it just needs to be said that Cornwall and Oxford need to be given a lot of commendation, really, for pioneering this approach. It's a shame that there's not lots of others doing it. So I'm wholly supportive of the work they're doing. But there's no question that this is a work in progress. There's a long way to go before everybody's going to agree the best way forward. And one of the questions that I had for you, James, was, and put me right if I'm wrong, but the Cornwall calculator doesn't actually factor in or doesn't seem to factor in the projected canopy spread for retained existing trees. If that's wrong, then put me right. If it's right, have you got an explanation for that? Because quite clearly
that is
they
correct.
are.
We don't have that, Jeremy. The reason is that's much harder. Obviously, we're implementing it. As you say, it is a work in progress. It is under review. I am working with the spreadsheet. It's much harder data to predict. When we have improved modelling that we can incorporate into the spreadsheet, we will incorporate it. Certainly, we have had a few submissions where there are young trees on site, and where there hasn't been space for new plantings, and as part of the justifications for not reaching the 15%, consultants have said we have X number of young trees on site. These will make up a certain percentage of that.
Great, thanks so much.
Right, thank you. The floor is now open to anybody to ask a question of any of our speakers, or a question that you want to put to all of them. So please feel free to do so.
John, David Winlow told me that he's got a question, but he can't find the put his hand up button. So David, if you're there, do you want to ask it?
Yeah, hi, hope you can hear me okay.
Yes.
On the camera. Thanks for the presentation, and just to help us out with some market research really for arboricultural software development. How does the panel view the possible alignment of tree canopy growth metrics with the woodland carbon code in the planning process? And secondly, what are your thoughts on translating these results into a dynamic combined carbon sequestration and tree canopy growth 3D visualization tool with forward projections? Thirdly, and lastly, how would you view the concept of using the tree and hedge 3D visualization tool with machine learning based on the data input to identify information such as tree canopy growth trends or tree survival rates represented in graphical formats?
Right.
And repeat if necessary. Sorry if that's...
Can we take the first one?
Yeah.
I think that was linking what we've talked about in terms of tree growth rates to the woodland carbon code.
Yeah, as an acceptable kind of UK standard, which something developers or investors might look towards for a UK standard.
Can I put that to you first, Luke? Would that be all right? I think you're muted.
Yeah, you can try. I mean, as a standard, I think, it depends really on whether other metrics for carbon capture and sequestration come forward that are accepted more widely. So I mean, but in principle, it's having in principle having a metric of carbon carbon sequestration, capture and storage is useful, and it I don't know if I'm really answering your question, David. I feel like I'm waffling, but yeah, so it's useful, and I think could be valuable.
Okay, and how would you see that then being translated into a 3D visualization as technology now allows, which really sort of transfers from you or the surveyor transferring their data that they capture out on site into an automated 3D model?
And grown over time? Yeah,
in kind of say 5 yearly projections that you could say, I want to have a look at this in 2030 or 2035, push a button and it will grow.
Yeah, so
dimensions.
I mean, so that's where allometric relationships, equations, sorry, is the right term, really help. I would say that's great, but again, it comes back to us needing more. The information that we have, I talked about some holes in it already in 2 dimensions, and now we've added another dimension. So that then creates an even wider gap in its reliability. But but we've got what we've got, and I think we can do something with it.
Yeah, and maybe 3D would be a really kind of useful tool to kind of visualize and pan around that includes root protection areas and their influence on buildings over time.
Yeah, so you've just introduced about several more parameters,
Yeah, there's
including
many more, I
how the
guess.
building's constructed and what type of soil there is, and whether there's other underground issues. So yeah, I mean, we, you know, for our work, when we do 3D modeling, we generate a snapshot of the trees and root protection areas, etc. But you know, we again, very in the same way as I've described, we have to be really clear about what the parameters are, what the variables are, and what are the limitations of the model.
Yeah,
But decisions are being made based on these things. So yeah, I think all of this is possible and useful, but there's still an illustration. Yeah.
Thank you, Luke. I think
thanks very much. And just finally, thanks again. How do you see that data being able to be used through kind of machine learning to identify trends in a sort of planning environment?
By feeding it lots more data.
Yeah. Okay, it'll take
It's
time.
the only way, isn't it? I mean, without adding the data in, you know, then machine learning has got nothing to learn from. Yeah, so we still need more data.
Okay, that's really helpful. Thanks very much.
Absolute pleasure.
All right, thank you, Luke. That's
I mean,
great.
I'm not an expert on this, but if you, and the one thing I have learned about AI is that if you put rubbish in, you get rubbish out.
Yeah, I mean and that's true of all the systems we work with, and unfortunately, the rubbish looks the same as the good stuff when you kind of present it. That's a very fair point. Can I ask Luke? I know you kind of, James, you answered Luke's question briefly, but if I could actually wide open that up, Luke Taylor-Tamblyn, are you able to ask your question, or I can ask it for you?
I'm not very good with Zoom. Can you see me?
Yes, we can see you.
Hi, how you doing? You're all right. Yeah, no, my question was to James. On the canopy cover, I've worked on the High Wycombe one and in Bucks quite a lot, especially on strategic sites. And I've found that where you don't have a large existing canopy cover, you end up with a site, you're trying to get 25% in Bucks onto the red line. And then we've also working along with B&G and Grassland and end up having competing calculators. So my question was to James actually is how he views that. I've had a different experience in Bucks where they've pushed the canopy calculator over B&G, which was interesting. But yeah, I was wondering, it's more about how you work around those competing calculators. And I've also had designers sort of say we're designing by calculator now, and how you sort of deal with that rhetoric.
Yeah, as far as we're concerned with the canopy calculator, BNG does take priority. Actually, on one of the slides, if it has a significant impact on the balance of net gain or the provision of the 10% net gain on site, that is sufficient justification to not achieve the 15%. So yeah, BNG is a national thing. This is a local policy, so we made that decision.
It's a nice, clean answer.
Yeah, no, that's appreciated.
Yeah.
Michael Sankus has got his hand up. I've just seen.
Do you want to go ahead, Michael?
Yeah, I'm actually sat at a pub trying to do this. It's a hard thing to do, but fantastic work by Oxford and Cambridge. We're in the process of going through our local plan at the moment, and I think it seems the current drive is to produce local plans which are far slimmer, more strategic, with a fair absence of DM policies, based on the fact that we'll have some national DM policies. How do people think we might achieve those same policies as Wycombe and Oxford and Cornwall are producing at the moment?
Interesting, because the two people in the room have already done it.
That's it, but now it's changing, isn't it? So
yeah.
I would say, you know,
believe.
there is a national push for tree strategies. Tree strategies can be key parts of this. Tree strategies won't just be involved within assets, within local authorities. It will also be involved with the planning system as well. And if you have a good solid tree strategy with decent aspirations, you can link that into local plans and you should be able to achieve suitable outcomes.
I think it's just that the local plans are going to be very thin in terms of hooks to hang things on.
Yeah, I think
that's where we would use the tree strategy to give some extra hooks.
Yeah, but the hooks have to come from the local plan. Your strategy's got the detail if you've got the hooks.
Can I just ask a question here? Why a local authority? Why is there such a nervousness about sort of, well thought through adopted strategies that just sort out what needs to be done, and so then everybody gets on and does it? I think we spend far more time arguing things with development and so on than the time would be taken if they just knew exactly what to do in the first place.
I think it's tying it up with development though, Sue, isn't it? You've got to make that policy that allows you to be robust in your decision making.
Well, exactly, and isn't the strategy that the strategies the route to that? Because if the strategy is well thought through and deliverable, then you've got a robust method of making your decisions. I feel there's a kind of mismatch between a fear of restriction, so we can't develop and grow and whatever, and yet by not having it, we haven't got clarity, and so we actually create other confusions.
Maybe. Well, has anyone got any experience of the more slimmed down versions of local plans that they're aware of, they're seeing as a draft?
Our local plan is just about to be adopted to 2040. It actually been held up, but not related to green infrastructure policies, just about the housing numbers that we said we could manage. So just on that basis alone. So my personal experience, or that of our planning policy team, is that we haven't had any issues with form and thickness of our local plan.
I think the problem, Chris, is that the process has changed now. So when you started your local plan, it was a different there was a different ecosystem that we were working to.
Well, it's outside of my area of expertise then, in that case. Do you have any planners on the panel, or listen
or on the call?
On the call, should I say?
Step forward if you're there.
Maybe, Sue, I can take this up with you outside this meeting.
Yeah. I did see David Brassfield had actually quite an interesting question. Is there, or shall I?
David?
I can see his lovely tree.
Yeah, do you hear me? I had difficulty getting my microphone to work before. First of all, thanks to everyone. I really appreciate the high nerd factor here. No, the question is, of course, how we can use this tree canopy assessment for other purposes, and the mobility of urban wildlife through biological corridors is also important to establish. So my question is just how this can be used to support assessments of biological corridors as well. Thanks.
Anybody? Chris, James?
I can pick it up if anybody would like that.
Go on then, Emma.
Hi, so I work at the University of Birmingham, and my background is in GIS, and we've been doing work recently looking at how you can map along the railway line, so you can think about connectivity, and Tree Canopy is one of these really useful layers that helps you think about how different animals can move through their environment. And the focus particularly on that project is thinking about if you're Network Rail, how can you receive maximum bang for your buck? Where would you want to invest in biodiversity? So I think to answer your question, yes, absolutely, it can be done, but I don't necessarily know if the people working in this sort of area are on the call today. But if you wanted to drop me an email, I could maybe tell you a little bit more about some of the research that's been happening at the university. And also out in the real world, people like Network Rail, and also the UIC, so the International Union of Railways, they also are trying to think about how they can promote connectivity along the railway lines.
And can I just add, I mean, don't we have Natural England's Green Infrastructure Framework, where the ambition is that actually we get this connectivity at every opportunity? And local nature recovery strategies, isn't it part of what we should all be actually trying to do?
I think so, and there are loads of really whizzy things you can do now with GIS and models that you can run so that the GIS is doing the work for you.
Right. We had another question from John Fraser actually a little while ago about aspirational canopy targets. John, if you're there. Or not. I can ask. It's really kind of how important is it that we have an aspirational canopy target, particularly if we fall short due to onslaught of pests and diseases or other unforeseen factors? John, there you are.
Yeah, sorry.
Widen the question for my.
No, I was really just making a point rather than asking the question, because people were saying, how can we predict the impact of new pests and diseases, climate change, etc., etc. But I think the point is really, and if you look at 330-300 as an example, it's having that aspiration, isn't it? Going for 30%. If you fall short of that and you end up with 20%, then at least we've made a serious improvement. I mean, in Dudley, where I work at the moment, I've been working with our GIS officer quite closely. And once we've taken out all of our nature reserves, parks, etc., our canopy cover is only just over 10%. So, any improvement that we can make on that. So in our new local plan, what I've proposed is, instead of going for arbitrary tree replacement numbers when trees are lost for development, that we go for a canopy cover target. I've just been in touch with Matt, who Luke was bringing up earlier, who's written a great article in the Old magazine recently, and he's been very generous in sharing his work with me, which is a really, really good starting point for us as a planning department to try and to model what's going to happen in 10, 20, 30 years time. But I think we know that canopy cover is what's important. It's not just numbers of trees. And again, we can also touch upon the points that were mentioned earlier about establishment rates rather than planting targets, etc., etc. But I think it's having that aspiration and then being able to back that up with some kind of model when we're trying to sell it to developers, or whether we're trying to sell a local plan to elected members, etc. So it's really fascinating listening to what everybody's had to say about it today, and incredibly helpful for me. Well, thank you very much for everybody that's contributed to this.
Thank you. Can I ask you to turn your mic off, John, because you've got a lot of interference in the background. Thank you very much.
Harry's got a question. And you've turned your camera on.
Yeah. Hello.
Yes.
Yeah. So I am currently doing my thesis on
Harry, you've gone on mute.
Now can you hear me?
Yes.
Okay. Sorry, I'm currently doing a thesis on carbon sequestration and its relation with urban heat island mitigation. So I was trying to use Tree Canopy for this purpose, but when I'm looking at the carbon benefits, so all I can see is that it's the same value, 1.365 carbon rate and 5.005 for sequestered annually in trees. And for stored in trees, it always gives 34.281 and 125.697 for carbon dioxide equivalent rate. So I just wanted to ask how to calculate the carbon sequestration capacities by iTree, and why does it give the same value for different areas?
I can probably answer that one. iTree's got, there's two tools within iTree, big tools, iTree Canopy and iTree Eco. iTree Canopy does exactly what you've just said. It takes a generic figure and effectively treats all trees as the same, because it's an approximation tool. So it allows you to approximately move from a tree canopy figure to a tree carbon benefits trigger, key carbon sequestration figure. If you want a more accurate model, you need to go into iTree Eco on a species basis. A proxy for getting between the two will be to take somebody's iTree Eco report for a city that you're interested in and use their figures, scale them up at the canopy level. That would give you a sort of halfway house.
Okay.
But
Thank you so much.
it's how the model is built. Yeah.
Okay, I will try to explore iTree Eco now.
Yeah.
Thanks.
Okay, I think we are pretty much out of time, everybody. So it just lets me to thank our excellent speakers today. It's been a really excellent session, a lot of detail and some very impressive presentations. So for Deanne, Hannah, Luke, Chris and James, thank you very much for your time and all the effort you put in beforehand. It's been superb. Thank you very much. And again to Emma and Sue for hosting and putting this on.
Thank you to John for chairing so well. Thank you very much. So I put in the chat when the next seminar will be, which will be the 13th of May, and in light of what we've talked about, it's resilience through planning for trees. So perhaps we can nut out some of those planning issues then. I think we can close the meeting. Emma and I said we would stay on, for whatever, 10 or 15 minutes afterwards, if anybody had any other things they'd like to raise about things they'd like us to do or would like to contribute to. One thing we have introduced, and we'll tell you more about it in the email we send out, is a sort of research roundup and implications for practitioners, where we're going to call for researchers to give us a very short resume of some of their research work and what we all as practitioners ought to know and understand about it. Because quite clearly we're dedicated to getting research into practice, and this could be a way of actually helping that. So I'll close the meeting, let everybody who wants to go. If anybody's got anything else they want to say, stay on and say it now. And I'll save the chat.
Thank you.
Thank you.